Welcome to our app on the binomial distribution. The binomial distribution is what arises when you do what's called Bernoulli Trials. So that's what this is. So we've got, I'm on the main applet part, the part that actually does something right now. Just real quickly, you can look at the instructions. I don't know if you'll need them if you're watching this video. Math notes. You won't need them so much if you've done the lecture, but I'd read them anyway because it's always good to get a second layer of spray paint, you know what I mean? Help burn things in a little better. You might catch a tidbit or two that you didn't realize before, deepen your understanding. It's worth it. At the very end, we got a quiz, of course. Heads up on question number 2. It's a little tricky. You got to think that one through. Anyway, Bernoulli Trials, back to the applet part. So on the upper left, you see define the experiment. There's only 2 parameters, an n and a p. These will define the experiment. P, of course, stands for probability. I've got a 0.5. You might think of like flipping a coin and it's a 0.5 that you get heads. So that's what that probability is. Every time you flip a coin, it's a 0.5 to get heads. The n, I've got set to 50 right now. And I could set that lower, so I'll just kind of go in the text box here and let's do 10. We're only going to flip 10. We're going to flip 10 coins. That's what the n means. You can think of it as taking a handful of 10 pennies and flipping them, or you can think of flipping one coin 10 times, and what you do is you count how many times did I get heads. How many times did I succeed in getting heads? Succeed is kind of the official lingo, success and failure. Instead of heads and tails, it's success and failure. Try to get heads. I succeeded. Yay! I failed. It was a tails. Oh, bummer. Anywho, so that's you can play with these parameters. If you don't want a fair coin, you can make the coin be only 20% of the time does it come up heads. But I'm not going to deal with that now. I'll just say it's 50-50. Anyway, so you can change those 2 parameters. I don't think you can set n higher than 50, but anyway, you can play with those 2 parameters and then run the experiment. See the blue button that says 1 time. I'm going to run this experiment 1 time. Boom, I hit the button and I get a result down there. So notice the result is SFSS. What does that mean? Success, fail, success, 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 fail, success, success. In other words, I got 8 heads. That's kind of a lot. I wasn't expecting that many. But anyway, 8 heads. So success means I got what I'm looking for, and we'll just say we're looking for heads, and failure means I didn't. And that's the thing to keep in mind is when you hit the 1 time, you're not tossing 1 coin, you're doing the whole experiment 1 time, and the experiment is, hey, how many heads do you get if you flip 10 coins? And the answer here is 8. Or at least that was the answer that time. It was 8. Now, if you look over there on the bar chart, you'll see a little bar where the 8 is. So, of course, it goes from 0 to 10 on the x-axis, and it's a little bar on the 8. So I'm going to run it again. Hit the 1 time button again. Boom. This time I got 7 successes. Seems a little more reasonable. Shouldn't we expect about 5? I thought 50% of 10 was 5. You'd expect 5, wouldn't you? But that doesn't mean you expect 5 every single time. It's not like I can guarantee getting 5 this time. That's what random means. It means you don't know what's going to happen. There might be a range of possibilities. In this case, anywhere from 0 to 10 is possible. So which means sometimes we should get 0. Sometimes we should get 10. Maybe not often, but we should. So I'm going to run it again. Boom. What do I get this time? I got 7 again. Wow, this is kind of flipping high. Oh, there's a 4. Okay, that's on the low side-ish. And you just kind of keep flipping the experiment, watching the bars show up and see what happens. Now, after a while, I've rigged this thing so that after you've done it 5 times, it now says, hey, why don't you do it 10 more times? So, yeah, let's do that. Let's pick up the pace here. Let's get some results going here. So I did it. Now we're up to 15 total runs, and did we ever get 5? I don't know. This is weird. Try it again. Are we ever going to get 5? Boy, this is weird. Try it again. Try it again. Okay. You know, these computers aren't really random. They've got these random number generators that are sort of random, but they're not. So, yeah, dip at 5. And by the way, like I was just saying, I can't expect that we'd never have a dip at 5. Maybe we should have a dip at 5 now and then. But look how many times I've run the experiment, 55 times, and I really haven't got a 5 very much. I can scroll on my list of results. I see a lot of 6s. There's a 5. I see some 4s. There's a 6. Yeah, that's really right. Let's do it 100 times. Boom. Okay, we're starting to fill in that in the middle. Seems like we're still leaning towards 4. 100 more times. Boom. 100 more times. Boom. Okay, so it does look like at least 4, 5, and 6 are the most frequent results. Um, Boy, we never got a 0 or a 1, it looks like. We did get at least a 9 or a 10 in there somewhere, judging by the darkness of that line there. Now the infinity is a special button because what that means is keep running the experiment over and over and over and over forever, without stopping ever. That's what infinity means, without stopping ever. So if I do that, okay, get ready, boom. We never stopped, ever. We never, ever stopped. And yet somehow we've got a result. Well, of course, these are no longer counts. I can't count. How many times in infinity did I get 5 heads? It's a ratio, of course. What percent of the time did I get heads? And it looks like it's something like, I don't know what it is. Actually, you want to know what it is? You can do two things. You can look on the left here, where it says list of results. Because I've done it infinite times, these are no longer counts. They're ratios. What percent of the time? I got 0 heads about 0.097% of the time, and I got 1, 2, 3, 4. Here's 5 heads. Looks like 5 heads is only about 24.6% of the time. Even though we call it the expected value, that's what you expect on average over the long haul, is to get 5 on average over the long haul. But we actually got a 5 only less than 25% of the time. Interesting. And so on. So it's got the actual probabilities for whatever result you want. How many times did I get 7? Exactly 7. 11.7% of the time. Now this thing on the right, where it says theoretical probabilities, right now it says the probability that you got less than 0 was 0. And the probability that you got exactly 0 is 0.000977. And the probability that you got more than 0 is 0.999. Okay, well you can hit this plus button and say, well, what about less than 1? Less than 1 means 0. And so looking back over on this thing, of course, that's the same number. So less than 1 means 0. Is this? The probability of exactly 1 is 0.009766. The probability of anything more than 1, which of course is the all of the blue bars added up. And you can go like this. So here we go. Less than 3 would be totaling up all the green bars, like a 5.5% chance of getting less than 3. Getting exactly 3 is the red bar, about 11.7%. Getting more than 3, that's all the blue bars added up, 82.8%, and so on. And of course you can reset, like back to your starting point. I want to run more than 10. I want to run, I don't know. I want to run 40. I'm going to run 40. 40 runs, and this time, let's pretend I'm almost like rolling a die. So the chance of getting a 6 is 1 in 6, which is 0.1667. So 40 dice. How many 6s do you get? I just got 7. 7 6s and 40 dice. Sound right to you? I just got, do it again, 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 do it again. You can do it again and again and again and again. 100 times. Okay. So it looks like, yes, it's you notice it's peaking somewhere at about 1/6 of the way to 40, because you expect a 6 about 1 time in 6. So what is 1/6 of 40? It's a little more than 6. So looking at the list, I got 8, I got 6, I got 8, I got 7, I got 8, I got 4, I got 7. Yeah, something like that. So yeah, something like that. 100 more times, 100 more times. Let's do it infinite number of times. Boom! Now it's all probabilities. And so of course the curve looks nice and pretty. And you can play around with this, and you can do this kind of thing, and whatever. There she blows. It's a cute little experiment. So you want to use this when you're answering the quiz questions, by the way. That was the whole point. Is the quiz is, well, there are a couple of knowledge questions, but like it says here, like question 5, set n equals 20, p equals 50. What is the probability of 10 successes? Well, you come on over here and you figure it out. So it's to make sure you know how to use the app and all that stuff. So I hope this is kind of a fun little app to use. I was having fun making it.